In this problem, it says a belt runs on a pulley of radius of 8 and 60 revolutions per minute. Find the angular velocity. What we want to think of angular velocity is the change of our angle over time. And looking at this, if we're thinking about our angle, it says it makes 60 revolutions per minute. 60 revolutions per minute means that it's going around the circle 60 times in 1 minute. So if we want to think about that in angle, is that it goes around a circle 60 times, so 60 times our 2 pi, because 2 pi is the radians per circle. And that's going to be our conversion for our angle. So we will have our angle is 60 times 2 pi. So our angular velocity is 60 times 2 pi, and that is going to be our radians, and it says it's per minute, so per 1 minute. And now if we read our problem a little closer, it tells us we want to have our radians per second. So let's do an additional conversion. We know that in 1 minute, there are 60 seconds. The reason I need to put my minutes on top is I want my minutes to be able to cancel out. So if I cancel out my minutes, my 60s cancel, my angular velocity is going to be 2 pi radians per second. The next one says find the linear velocity, and linear velocity is distance over time. Linear velocity we can think of as arc length over time. So it says find the linear velocity. Well, they don't give us enough information to have our s, but we know linear velocity could be, in replacing our s, we could think of it as arc length r times theta over t. Now replacing our information, we have our 8 centimeters. Our angle is going to be the 120 pi radians, because it made 60 revolutions, and that was per 1 minute. Now remember, they're asking us to find our centimeters per second, so we do have to do our conversion, and we could do 1 minute with 60 seconds. From here, your minutes will cancel. I'm going to reduce my 60, and I end up with my linear velocity as 16 pi. I'm highlighting what we have left. 16 pi, and our units will be centimeters per second.